we have two kids that are fighting over a toy. So here's the toy. And then we'll have person 1 over here pulling with force P1. We have person 2 over here pulling with force P2. And the toy is sitting on the ground with friction. So if we're given mass of the toy, static friction of the ground, dynamic friction of the ground, pull from the first kid, pull from the second kid, we need to find, does the toy move? And if it does move, what is the acceleration? Okay. So let's fill in some values for this. Let's say that the toy maybe weighs 5 kilograms. So it's a 10-pound toy. And then we'll have static friction maybe being 0.6, dynamic friction being 0.3. And one person is pulling with a force of 150 newtons. And then the other person is pulling with a force of 110 newtons. So we know that if the object moves, it will move towards person 1. But we don't necessarily know that person 1 is going to get the toy, because person 1 has to overcome the force from person 2 as well as the force of friction, because the toy is not on a frictionless surface. So we will start out with step 1, which is drawing free body diagram. So we actually have 2 of the forces already on here. So we just need to include the weight of the object and the friction force. So we'll have the mg pointing down, we'll have the normal force pointing up, and then is friction on here, would the friction force point to the right or to the left? Friction force will point to the right here, because the block, if there was no friction, then person 1 would totally win this contest. So friction is opposing the force from person 1, because that is the way that the block would move. So we'll put our friction here pointing to the right. Okay, now in this situation, friction, if we want to find out whether or not does the toy move, we're going to use static friction. Then if we discover that yes, the toy does move, then we switch to dynamic friction and we can find the actual acceleration value. So this is because first we have to do our static check, because the static friction is what's going to need to be overcome in order for something to start moving. So we'll just write that here as a reminder. Check for mu s, static check, and then we will calculate at mu d if it does move. Okay, so we got step 1, our free body diagram. Now we need to do our coordinate frame. So we will put x along the direction of motion, and we will put y perpendicular. And then we need to write our equations. So we will write sum of forces in x, sum of forces, or then find friction, do the static check. Let's write all these down. So the game plan here. So we'll do sum of the forces in y, get normal force. From normal force, get friction. And then we'll do the static check, see if it moves. So that would be find the sum of the forces in the x direction, get acceleration. Okay, so here we're going to solve sum of the forces in y. Sum of the forces in the y direction equals 0 because the block is not moving up and down. And the only forces in the y direction are the normal force going up and the weight going down. So this tells us normal force equals mg, which is the 5 kilogram toy times the 9.81 meters per second. And this is 49.05 newtons. So then from normal force, we get friction force. So we'll go ahead and calculate static and dynamic friction both because we'll need the dynamic for part 2 of this question. So static friction equals the coefficient times the normal force. So that would be 0.6 times 49.05. And then the dynamic friction is going to be 0.3 times that 49.05. So plug that into a calculator. And 29.43 newtons is the static friction. And then the dynamic friction should be about 15 newtons. So what do y'all get for that? Yeah, 14.7. 14.7 newtons for dynamic. Okay, so now we're going to do the static check, which basically needs to see, so is P1 over here going to pull hard enough that it overcomes P2 plus friction? So our static check going to the left, and we're going to compare that to the forces going to the right, which are P2 plus static friction. So P1 over here is 150. And then P2 is 110 plus the static friction, which is a 29.43. So this gives us 139. So P1 is greater than the P2 plus the static friction. So yes, that first kid is strong enough to overcome both forces and pull the block. So we know that the block moves. Or toy, whatever you want to call it. So yes, the toy does move. So now we'll sum our forces in the x direction and get acceleration. So sum of the forces in x, in this case, equals mass times acceleration. So now we put those forces in. Now going to the right, we have P2, which is positive x direction, plus the friction force. In this case, we're going to use the dynamic friction because we know that the block is moving. And then we subtract P1. And so now we can just solve out here, acceleration equals P2 plus FD minus P1 all over mass. So A equals, if we just load our numbers in, P2 is 110 plus the dynamic friction is 14.7 minus P1 is 150 over the mass, which is 5. So put all that into a calculator, see what you get. So we plug that all in, we get negative 5.06 meters per second squared equals the acceleration. And then we'll do a reality check on this. So does that make sense? Should acceleration be negative? Well, we know that the block is going to move towards person one. We had calculated that. And we put our x direction positive to the right. So we should get a negative acceleration. So negative 5.06 is a reasonable answer.